Today on the traffic system, I'll be showing you guys what happens when a car catches up to a slower car and what happens if the car, well, is no longer blocking the way and so it can go and continue on. And the same thing, of course, when dealing with splines. If it catches up on a section where it is too fast, it will slow down and match it. And as well as even an immediate stop, it will slow down in time. Now, it will not automatically set up the next car to go for the intersections. That'll be covered next time. But the main thing for today is to go over slowing down and speeding up no matter the distance you need to. So that way you can do a slow stop when you need to, and a sudden stop like something just jumps out in front of you, or it just becomes a red light right as you're about to get to the intersection. Things of that nature. This is the next part of the traffic system. So let me show you how to set up all these new changes. Here's our current traffic system. This is what we left off with last week. And it's working well. We have cars coming in, and we have some that have currently a green light where they can follow one random direction, another one, and then another one. So we set up the intersections, but of course, this is only for one car. If we were to have a second car behind this one, and we told it to be faster, at the current moment, it will do just that. It will get faster and then just continue on, going right through the car ahead of it. And that just doesn't seem right, does it? So all of the changes are pretty much going to be on the main car blueprint that we've been working on. So that's where we're going to be for this time being. And we're going to need a few things. We're going to need to manually be able to trigger acceleration, and currently there's no way to do it manually. And we need to trigger the deceleration when we need to as well, and be able to control the distance at which it decelerates. Because right now we have a set distance here, and we don't want that. We want to control that. So let's go ahead and start at the acceleration part. I want to actually control when this triggers. So I'm going to right click and do a custom event. I'll just call it start acceleration. Instead of just plugging in all the way through, I want to first check that the drive forward timer is active. Because if we're not driving forward, if drive was never triggered, I don't actually want to accelerate. Because remember, this doesn't move the car forward. It just changes the speed that we're set up with. So because of that, what I'm going to do is use a branch here, and then I'm going to grab the drive forward timer. I'm going to just right click, get drive forward timer, and get it. And I can search for is timer active by handle. So if it is active, I want to say, okay, you can start the acceleration. But if it is not active, we're not going forward, we're not driving, don't accelerate the actual speed. So false will just go with nothing. So for this, I will go ahead and detach it from here. And then we can just move this to the side, and then off of the drive, we can just say start acceleration. So then it will do this as it was doing before. But there is a scenario where we trigger this, and for whatever reason, we tell the drive to stop. So if we tell the driving to stop, we're definitely going to want to stop this timer as well. So what we're going to do is we're just going to take all of this and kind of move it a little bit up to give us more room. And I'm going to promote this timer to a variable. So I'm going to right click, promote to a variable. I'll call it acceleration timer. It'll be set here. And that way we can go ahead and cancel the acceleration timer from this clear handle. We can remove this redirect. And then on acceleration, I'm going to do the same check. Is the timer active? So here, if the timer is active, it'll return true. But if the timer is active, then we're good. So continue on. And this is from the acceleration. If the timer is not active, I want to stop this timer. So I'm going to take this clear and validate timer by handle and acceleration timer, copy it over here, and basically we're just going to stop the timer if it is not driving. This is effectively a safety measure that if we are no longer driving while we're accelerating, stop the acceleration. Now, what about the deceleration or the stopping of the car? Well, we're going to do the same thing for the stopping of the car. I'm going to promote this timer also to a new variable. I'll call it stop car timer. And just like the other one, I'll go ahead and grab it and plug it in into this one so we don't have to run this all the way through. There's also now a few timers in, so I'm going to select them and put them in a new category. I'll make the category just timers, and I'll just put them in here for organization. So there we go. The reason I'm promoting it to a timer here is because when we stop the car, I want to check if the stop car timer is active, and only do this if it is not active, because that means we're no longer stopping the car. And the reason for this is because if we were to try to say stop car multiple times, it would reset this timer. So instead of continuing otherwise, it would basically just try to restart this again and again and again and fail to do so because it'll never wait this long. So this gets around that problem. The next one is the deceleration distance. As you saw from the little preview at the beginning, there's a scenario where the car in front of you just suddenly stops because there's a red light, for example. and you need to now suddenly stop at a much shorter distance than you're by default going to. Or in an intersection, a light turns red, but you're very close to the end, and your current deceleration distance would put you in the middle of the intersection. That's not good either, so we need to adjust the deceleration distance. So instead of using this deceleration distance, we're going to make one more. So I'm going to duplicate this deceleration distance and call it max deceleration distance. And the current one we'll be using everywhere, I'll change to current deceleration distance. This way, I don't have to replug it in everywhere. The main thing is to compile, and on the current deceleration distance, you can leave it at whatever value you had. I'll go ahead and set it to be 0 by default. And on the max is where we want to make sure the max is correct. 100 is way too quick. So I'm going to change the max deceleration distance to 1,000. That seems like a good slowdown. But of course, current is not current until we tell it to be current. So on begin play, we're going to take the current deceleration distance and we're going to set it with the max deceleration distance. So at the very beginning, just go ahead and set one with the other. So we only need to adjust this value and it'll take care of the rest. I'll also go ahead and move this max deceleration distance to the controls, and I'll expose it just so I can control it per car if I wanted to in the editor. Obviously, when things are going to be procedurally spawned in the end, this is not going to be needed. This is just for playing around and testing. Now, because it's now going to be a current deceleration distance, we're no longer going to be checking if it is less or equal to 0, because we're not trying to see when it stops. We're trying to see when it gets to the speed that we want it to be. So we actually need a new variable here. For convenience, I'm going to duplicate the current deceleration distance, and I'm just going to call it deceleration goal. Now we're getting a few speed related settings here that we're just keeping track of. So I'm going to just put them all into a category. I'll just call it speed, and any variable here that has to do with changing of its speed, whether acceleration or deceleration, I'm going to put in this category. So we can keep this relatively organized. But now we have this deceleration goal variable, and that is actually what we're going to be comparing it to, whether or not we stop the car. Now, right now, we're stopping this timer and we're stopping driving. But we don't want to stop driving if we're not actually at 0. So unless we have stopped, we don't actually want to trigger the stopping of the driving. Right? We could slow down without stopping driving, because otherwise you slow down to a certain speed and then you just stop. And that's bad. So, few things. If it is less or equal to the deceleration goal speed, then I'm going to set the current speed to be this deceleration goal. So that way, if we undershoot it, then it will go ahead and just set it to be that number exactly. And then we definitely still want to stop the timer of the deceleration. But this last one should only happen if we are fully stopped. So if it is less or equal to 0, then we go ahead and actually stop the driving forward entirely, because we have come to a full stop. We'll decelerate however much we need to, at the distance we need to, come to the speed where we need to be. If the speed is not a full stop, then we'll just stop decelerating and we'll continue on as we were. But if it is a full stop, we'll go ahead and say, okay, enough driving. So this is good. We now have the stopping of the car and acceleration. Honestly, instead of stop car, I should now call this deceleration. There we go. Let's move them all together. So we have acceleration and deceleration. And now we need to actually check for the car ahead of us. And there's going to be two different ways of checking, of course, based on whether or not there's a path that we're on, because potentially it is curving and we want to make sure that we're checking in the right location, or if we're just going straight ahead, because we're not on a path, we're just going straight until we find one. So I'll go ahead and make a new function. I'll call this trace for car. Now down the line, potentially we'll be combining these traces together. For now, I'm keeping them separate. One, for convenience of the tutorials, and two, it makes it a lot more manageable to kind of figure things out as we're going on. But once everything is working and everything is working well, it'll be easier to see where we can actually go ahead and clean things up and merge things down and optimize. Now, cool, we have this trace for car. Let's go ahead and plug this in so we don't forget to first. And that is going to be in this drive forward setup. So when we're driving forward and we have a spline we're following, we're tracing for intersection. Well, this is also where we want to trace for the car. So we'll just plug this in right after. When we're not following a spline, we still do the trace for new path and, of course, trace for car now. So now let's go into the trace for car. The trace for car is going to be very similar to the other ones we've done. We're going to need to get the future position and rotation along spline, or just the forward direction if we don't have a spline. So the first thing we need to do is under components, grab our current follow spline, drag it out, right click and convert to validated get. Whether or not it is valid will determine on what kind of trace we do. Let's do the valid one first. And for that, we can use the trace for intersection 1 to get us started. So what I'm going to do is I'm going to just grab all of this, grab this, and grab all the way up to this break hit result. I'm going to copy it. I'm going to paste it over here into our trace for car. And then I'll go ahead and plug this in and we'll start to organize this. First thing is we're not tracing for traffic road. We're tracing for vehicles. The other thing is we don't care about the end of the spline here. We don't need this end part. We just need to know the location ahead of us. So we don't need any of this. We just need along the spline relative to our speed 50 times ahead. This location is going to go into the start and into the end because we just need a simple sphere trace at that point ahead. And so we're checking ahead on the spline. This is good. And it's already set to ignore self, so we don't need to worry about it tracing on itself. So now let's say it does find a car ahead of it. Well, first of all, we need to know that it's a car. So from the hit actor, we can drag out and do a cast to BP car base, which is the current class we're at. So it's definitely going to be in memory. And using this, we can get some information, starting with what is that car's in front speed. So I'll drag out of BP car base and then get current speed. So now we can compare it to ours. If their current speed is less than our current speed, then we're going to need to slow down. And if their current speed is lower than ours, then we need to set ourselves a new deceleration goal. So the new deceleration goal, the speed we need to get to, is their current speed. So we can go ahead and just plug this all the way through on true here. So if they're slower, we need to match their speed. But we also need to change the distance at which we need to decelerate at. So I'm also going to set the current deceleration distance. If they just come out of nowhere and you just need to hard stop, right? The deceleration distance is going to be very small. Or if we're really fast, we might need more or less distance to actually decelerate. So we need to know what is the distance between us and this car along the spline. To get the values we need, we're actually going to need to go inside the get future position and rotation along spline because we need to know the distance of this position. We need to know this distance and we need to know this distance. The reason we need to know the two distances is because we need to know how far ahead along the spline is the car in front of us. Distance-wise, like real world distance, it could be right next to us or it could be very far away. Imagine a scenario where your car is right here and the car ahead is here, and we're going kind of in this direction. If we did just a distance check, then it would just get this distance. But this is a very short distance compared to this distance, which is what you're actually going to be traveling. So that's why we need to know the distance along the spline itself, relative to where we are to relative to where we're going to be in that location. Now we have the current distance along the spline and the future distance along the spline. So we could just output the distance in between the two. So let's go ahead and take this return node and add an output pin here. I'll call this distance travel along spline. Make sure it was a type float. And all we need to do is take this future distance and go ahead and subtract the current distance. So wherever we are in the world, we have a distance from the start of it. And this is the one at the end, the one we're going to be moving towards to, or the one we're checking right now with a trace. We need to know what the distance is between them. So one minus the other gets us the distance, and that goes into distance travel along spline. And now we can take this distance travel along spline and plug that into the current deceleration distance. Let's go ahead and just zoom out and just take this all the way through. And let's use some reroute pins to just have this go above the rest so it's out of the way. And with a bit more cleanup, there we go. So we're checking ahead relative to our speed. We're checking for the vehicles. If we find a car that is slower than us, then we set the deceleration goal. That is the speed that we want to be at when we catch up to it. And the distance to it is this distance. But we don't want to just plug it in like I did. The reason we don't want to do that is because we're checking middle of the car to middle of the car. But if we did that, we would actually collide into the car head. So we actually want to decrease that distance just a bit. So before plugging into the current deceleration distance, I'm going to do a subtract. So go ahead and subtract 200 distance from this, which should account roughly for the front of the car and the back of the car, and potentially down the line, we'll go ahead and have it automatically be populated based on the size of the current car and the one ahead. For now, though, a hard value here I think is fine. And before I plug this in, I do want to do one other thing to this number, and that is I want to make sure that it doesn't go into negatives. So I can drag out of here and just search for max float. So give me the max number between 0 and this. So if it ever goes below 0, 0 will become the maximum number, so it will become 0. That way we never have a current deceleration distance that is negative. So awesome, we now have the deceleration goal and the deceleration distance. So now we can go into our variables and the acceleration timer and make sure that we're no longer accelerating if we are. So we're gonna do a clear and validate timer by handle for the acceleration. And once we stop the acceleration, we can just say, stop the car. Now this will run stop car, which will run this. If we're not stopping, it will now start to stop. And even though we're gonna try to run this multiple times potentially, it doesn't matter because it's never gonna rerun this timer because of this check. So we're good to say stop the car. So this is the deceleration if there's a car ahead of us. Now what happens if the car disappears? Well, that's what happens if this is false. That means there's no longer a car ahead of us potentially. Well, the first thing I want to know is, are we currently accelerating? So we're going to grab the acceleration timer and say, is timer active by handle? So if it is currently running, then we don't want to do anything with it. So off of this false, we'll come here. And if it's false, then we want to do something. We want to start the acceleration. But I also want to only accelerate if we're not going max speed. So I'll grab my speed variables. I'll grab my current speed and I'll grab my max speed. And I'm going to check if they are equal. So if both of them are equal, then I don't want to do this. So now, if the acceleration is running or we're at the max speed, so or Boolean, then it will return true in either scenario, which means I can go ahead and use false to start the acceleration because we're not at the max speed and we're not running the acceleration already. Now, what's the scenario of this happening? Well, that's intersections. You can be running on one spline on that intersection spline and another car is running on another one. But before it kind of goes in its own direction, it's still close enough ahead that it's going to get in the way. So we need to make sure it gets out of the way and then you continue on. So fantastic. This is the hard part really, because the bottom one is very similar. We actually don't need this one anymore. So if we're not following a spline, it's a little bit simpler. I'll go ahead and just take all of this and duplicate it down below though. For convenience, and I'll plug is not valid into here. And then I'll go ahead and actually just comment all of this above. I'll call this on spline car check. And then we're going to be working off of the spline car check. So when we're not on the spline, we actually don't need this. Instead, we need to get the current active location. So we need to use get active location. That is our start. We're currently somewhere. So now we need to know how much forward we're going to be checking. So right click, get active forward vector. So this is the direction we're facing as a vector. And then we need to multiply by how far we want to check ahead of us. Well, we need to do it based on the frame rate. So we're going to do get frame rate, and then we're going to multiply by two things. So we're going to add another input here. So we have two extras, and we're multiplying it by our current speed, and then the scale at which we want to do it at, which is again 50. So it's the same distance ahead as we were using here. This is the relative speed multiplier, and that's what this is. So this is going to go into our multiply of the get actor forward vector, and then this goes ahead and adds to this forward vector as our target sphere trace location here. So it's basically just tracing forward. After this is going to be relatively similar. We're checking if we hit the car. If we did, we adjust this. The difference is this deceleration distance, because the distance for that becomes a lot easier because we have a distance from this brake hit vector. So we can just use this and plug that into our minus 200 and our max 0. So we're going to close this up and I'll go ahead and rearrange this. So the distance at which it hits something, minus 200, make sure it does not go into negative. And that becomes the current deceleration distance. After that, same thing as before, clear the acceleration if we're currently accelerating and stop the car. I guess it's not really stopping the car, it's slowing down the car. We can rename it later, not very important. And just like the other one, as long as the acceleration timer is not active and we're not at the max speed, we'll go ahead and start the acceleration. So now that we have all of this, we can go ahead and comment this bottom one, something like off spline car check. It is possible to combine, by the way, these two, just using a select. Again, I'm keeping it separate, so that way it's a little bit easier to control. It's slightly different here. Instead of doing a bunch of select nodes, I have it separate. This is just more of an easy use for the tutorial. You can absolutely combine it and use a select. All you would need to do is for these guys, just use a select. So this one down here, and just check if the current follow spline, so this current follow spline is valid. You want the Boolean here. And you just plug that into this index. And now you could say it is either this one if it is not valid, or the top one here if it is valid. So you could use this same setup here, as well as on the current deceleration distance. And that way you don't need two separate traces here. I'm keeping it separate for easier visualization of the two different systems for the tutorial. For the off spline car check, let's go ahead and turn on for one frame here. Let's do some tests. Let's take these two cars And I'll just duplicate them over here. Now the car ahead of us is set to be moving at 1,000 units, and this one is set to be moving at 2,000 units. So if I hit Alt-S or simulate, you'll see there it's checking ahead, and then it's slowed down, and it's slowed down, and you can see it has effectively now matching the speed. And there it goes. Now we can make this even more extreme. So now this back one is at 5,000, and this is 1,000. So it's going to catch up much quicker. And as it gets to it, it slows down a little bit, slows down, and then we just go ahead and move this one out of the way, and you'll see this one zooms off back up to its full speed. Now let's see what happens here on the spline. You can see this one slowing down, so it's doing everything correct, and that one just ran a red light. Well, that's not right. What happened there? Well, that has to do kind of with our trace for the intersections. So in our trace for intersection, we're saying stop car when we have an intersection, but we are not updating now the new distance to it. Because we're now, of course, using the current deceleration distance. So when we get stop at intersection to be true, we want to set the current deceleration distance. Now the distance isn't to the sphere trace. The distance is to the end of the spline. So I need to know what is my current position along the spline and what is the final position of the spline. Well, we've basically already got that in the get future position and rotation along spline, right? We have the distance travel along spline. That is what we need. Now we just need to make sure that we're using the same value here of 50. I could, to make it safe, just use this distance here, honestly. And we'll need the same kind of math we were using before, potentially, but because this is the first car there, we could just go ahead and just plug this in all the way through. If we take a look here and we simulate, you'll see as these cars go forward, this first one, yeah, it doesn't actually stop where it needs to. And these did not either. The reason is on this trace for intersections, we plugged in the distance to the end. And because of the way we're tracing it, we're effectively off of the track at that point. And so it's no longer valid. So it doesn't really work because we need the current follow slider to be valid. And when it's at the very end, well, it's not valid, so it can't get the right information. So all we need to do is make sure that we stop ahead of time. So we'll do a simple subtract here. And let's say stop 100 units before the end of this place. And now if we take a look and simulate, it should now go, and it should stop where it needs to. There it is. And then go just like that. And of course, I'll pick a random direction to go as always. And one more time, just see that it's not a fluke, and we can have it go into a different direction. There we go, green again. This time it went right, and you'll see that once these turn green as well, these also go into their respective directions. Now this one, of course, has not gone. There's nothing right now telling the car ahead to let the cars behind them know. That is something we'll need to take care of in the next part of the tutorial. But now we have cars slowing down for each other, and as I showed before, it completely works also on straight aheads, and it's also very simple to test, where you just select the car and just move it out of the way, and you'll see it'll speed back up. We're slowly getting to the point where we have all the fundamental stuff set up before we can start looking into procedurally spawning the cars in automatically on these paths, and then combining it with PCG to get it all spawned in and working automatically, and then go from there. And hopefully you'll join me for this journey. In the meantime, as always, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord and everything is down in the description below, as always. And if you're looking for more PCG stuff, perhaps making the roads themselves, I recommend checking out this video right over here, so you can get started right away.